Hello civil engineers, welcome back to my YouTube channel on Civil Brains. So we are in the lecture number 4 on the series of one-way slab. So we'll try to see how this entire slab looks as of now, and we'll also try to see how the electrical pipes and all those things are given, right? So we'll go to the video once. So just concentrate on the slab. So this is how your slab looks once everything is finished. So you can see the crank on either side, and there's a lot of distribution bar which we have placed, and we know how the distribution bar has been placed. Again we know like I mentioned, if I show you the code book, if I go to IS 456, and if right now I'm in IS 456 2000, I'm in an extra D of clause 24.4. so here it is written D1.6. At a discontinuous edge, negative moments may arise. They depend on the degree of fixity at the edge of the slab, but in general tension reinforcement equal to 50% of that provided the mid span extending to 0.1 L into the span will be sufficient. So what do you mean by this? This actually means that whatever crank bar you have provided, that is what they have explained there, why this crank bar has to be provided and at what distance you have to provide this crank bar. This is what is explained there. Anyhow, this I have tried to cover in my class, in my online course, so we'll learn from there what is exact meaning of that particular clause. Okay, and based on that clause only we are doing a crank bar, that is we have cranked the bar and we have taken to the top, right? So that is the meaning of that, because you get a negative bending moment in this region, and in order to take care of that negative bending moment, you are cranking the bar and taking it to the top, right? So here also you have a crank on either side. So this is the entire slab, and after that again what will happen, you see there is a lot of cantilever portion. This is your cantilever, you can see there, right? So this is my cantilever portion. So in the cantilever what will happen, we know that if I take a beam and if I draw it here, see, let us say if this is my cantilever beam, so we know that we have something called as neutral axis. So this will be my neutral axis, right? And in the cantilever beam above the neutral axis we'll have a tension, and in the bottom we'll be having a compression, right? So if you know, right, from the fundamentals we know that. So I'll write it here. We have tension at the top. I'll write it here. Yeah, we have tension at the top and compression in the bottom. So since we have tension in the top, what we are supposed to do, since it's a cantilever, we'll be extending this bar. After this you can see in the next after some time I'll be showing you this cantilever portion also. Here what will happen, all these bars will be placed in this way, because since it's a cantilever slab, you are going to place the bar at the top line this way, right? So that is the practical importance of that, and that is where we understood that tension will be at the top, and that is how we try to place the bar. Right now it is not shown, but maybe in another 1 or 2 minutes I'll show you the complete slab once it is done with all those cantilever and all. So let me try to go forward, and this is that entire slab how it looks. Okay, so this is a typical behavior of a slab. So if you know that, so we'll be having a negative bend. So we'll be having a negative bending moment in this way, then we'll have a positive bending moment, then again negative, and again positive, and then slight negative we have. So this is a typical behavior of a slab. So wherever you have this negative, that is the portion. You can see a crank bar has been done from here to here, because up to here we had a negative. Again here it is a positive bending moment, so you require the steel only in the bottom. So that is why you can see you have provided only the bottom steel here, whereas again near the support from here to here you have a negative bending moment. So that is why you crank the bar taken like this, and you crank from this side. So this is the importance of your bending moment, and accordingly we are going to keep the steel on the side practically, right? So the other portion it's not done, so again we'll see that how those entire portion will be done once it is completed. So let me go forward a bit. Yeah, so now this, once all the slab is done, half of the slab is done, we'll be calling this electrical people. So this electrical people will come, and wherever is the junction point they are going to fix it. because before the casting of a slab we want all the electrical conduits and all to be placed in its position. So that is why these people will come and they'll be having a separate drawing with them, that is the electrical drawing, and everything will be mentioned there, at what distance you have to keep the junction, from where the wiring has to be done, where the pipe has to be taken, everything will be mentioned to them in the drawing, and based on it these people will do the execution. Okay, so now you can see here a lot of pipes they are passing through this. These are the junction boxes we have here, here and here. Okay, so this is that junction. From here you will be passing the pipes, and through that, once the concreting is done, no, next we'll try to pass those the cables, the wires through that, and that is how it will be connected to the switches and all. So you can see here the pipe has been passed, right? From here the pipe will go. So once the concreting is done, when you remove this bottom soffit, alright, so what will happen, this pipe opening will be exposed there, and from here we are going to pass the wires through that. So all this becomes my concealed ceiling. Oh, sorry, this all this becomes my concealed wiring. Okay, concealed pipe, what we can call. Yeah, so in this way we'll try to connect that with the elbow bend. Yeah, right. So I hope you have got an idea how this electrical conducting work will be done. So you don't have to do anything much here. Those electrical people will be doing, but only the thing is you should take care of the checklist, because when you work as a site engineer you'll be having a certain checklist. Okay, so this is a checklist what we have, checklist for cutting, bending and positioning of the reinforcement. So for the bar bending you have to check all this checklist, whether these people are doing the work properly or not, whatever reinforcement they have placed, whether it is according to the structural drawings or not, and also you have to make sure whether they are given the covers to the reinforcement, relative positions of the bar, spacing of the bar, each and every spacing you have to check. Okay, and that is why it becomes very important. Once those bar bender try to mark it on the steel board like we have seen, you have to go and check whether exactly at the 6 inches they have done the marking or not. Then the lap length locations, provisions of chair, each and everything you have to check. Other than that, this is a checklist prior to concreting. Before the concreting work is started, there are certain checklists. That means once all the slab reinforcement work is done, let us say tomorrow you want to do the concreting, so today, by today evening, you have to take care of all this checklist. That is, check for the cleanliness of the area to be concreted, right? We'll see what is this, what do you mean by this. First let me finish this video. So now you can see all the slab reinforcement has been completed. You can see that cantilever portion also, no? This is my cantilever portion. So here also we have finished giving the reinforcement in the cantilever area. So first we'll see this and then we'll get back to the reinforcement area again. So you can see all the electrical works are done, all the slab reinforcement work is done. everything is done, and tomorrow we are supposed to do the concreting of this. So on the previous day I've taken a video of this, and as a site engineer you need to go and check according to the checklist whether everything has been done properly or not. Okay, so we'll try to go forward a bit. So this is that electrical pipe. Okay, now you observe here, like I mentioned, see it's a cantilever portion, isn't it? So this is my cantilever portion. So I given only the top reinforcement. You can see only the top reinforcement has been given, and there is no bottom reinforcement here. Like you can see we have a bottom reinforcement here, right? But whereas if you look into this particular area, into this particular, you can see only the top reinforcement, only the top reinforcement can be seen, and you don't have any reinforcement in the bottom. Why is that so? Because it's a cantilever portion. We know that tension will be in the top from the structure analysis and strength of materials concept, and the same fundament and the same thing is applied here as well. Now one more thing, see when we are giving the steel bar, why is that we have not stopped the bar here, right? You could have given the bar only up to here, because your tension, your cantilever slab is after this, after the beam it is a cantilever slab, right? Then why is that you have not stopped the bar, the top bar only here, but you have continued it here? You can see this is continued here, it is continued here, it is continued here, it is continued here. That means this is my cutoff portion. I'll do a cutoff. This is my cutoff portion, and beyond this also I have given my, I have continued by. What is the reason behind this? So this is called as back anchorage, anchorage. Okay, so what do you mean by anchorage? So what do you mean by this back anchorage? So if I put it in a very simple way, so let us consider I'm having a small table here. You can do it on your own, the small experiment. Let us consider this is a table. Okay, let me draw this in the yeah. Let us consider I kept a table here, right? And let me keep one scale. I'm taking a scale. So this is my scale. Yeah, so this is a small, so okay, this is a small scale what I have kept here. Now over that let me keep a small eraser. So I'm taking eraser so that it is easy for you to do, and let me keep a eraser over this. So what will happen the moment I keep the eraser here, no, what will happen, this let us the red color scale what I mentioned, it's a slab for you, okay, and this yellow color rubber is like a load coming on this. So moment you apply the load on this cantilever slab, what will happen, this is going to topple. Why is that so? Because the back anchorage whatever you are given, that means see this length from the outer of the table to this length, outer of the table to this length is where it's a long, I mean this distance is little long in comparison to the inner length. The inner length is this one, this is my inner length, right? So that is a back anchorage. This backside length what you are given, it's a back anchorage, and this is that cantilever steel what I have given. So due to this weight of a rubber, you can try to do it, weight of the rubber, what will happen, it will fall. So that is why what we are supposed to do, this whatever red color I have drawn, that is this purple color what you can see, this I have to extend again. That means instead of giving only up to, instead of continuing up to this distance, what I'm supposed to do, I need to continue this up to this distance. This is my back anchorage. So when I give this much anchorage, no, only then if I keep this eraser here, this scale is not going to fall. So that in the same way you can see this additional length of the bar we have given it here, this additional bar, this additional bar, this additional bar, even here also you can see here from here to here we could have stopped it, but again we have continued that bar up to here, isn't it? Same here, from here to here we could have stopped it, but again if you're not giving this much back anchorage, then again what will happen, your cantilever slab will fall. It will not be in a position to take the load. So that is why this is called as back anchorage, to give enough fixity to your cantilever slab. We are given this as back anchorage, and whatever is the back anchorage length that you're supposed to give, it will be mentioned in the structural drawing. From here to here you have to give, let us say 2 feet of the distance, or 3 feet you have to give, and accordingly the same will be executed on the site. So this is the practical importance of that, and hope you have got an idea. So we'll go forward again. Yeah, so this is a complete slab. So how to understand the structural drawings and all, we have a course on drawing reading. You can buy those course, it will cost you like 400 rupees for a single course. We have a course on quantity estimation. Yeah, along with that, so tomorrow is a concreting, right? If tomorrow is a concreting, today you should be knowing how much cement is required, how much sand is required, how much is the total slab area, how much concrete will go into the beam. All those calculations you need to do as a site engineer. So all those things you are going to learn in my quantity estimation course. I prepared a Excel sheet for that, and through that I've explained you how to take the quantities of all those things, and also how much centering plates are required, how to take out the beam centering, the slab centering, and all those things is covered in my entire quantity estimation course. So the cost of a single course is 400 rupees. Whichever course you want, you can buy it. And also as I mentioned, yeah, so all these are the different courses what I have a course on site engineering, quantity estimation, drawing reading, internship on practical aspects of building construction, ETABS, diploma in practical aspects of civil engineering, concrete technology, right? And if you want all the courses, it will cost you 2550 rupees, where you are going to get all my 7 courses. If you want to read, or if you want to take only the drawing reading, it will cost you 390. Only concrete technology will cost you 390. If you want a combo of quantity estimation and drawing reading, it will cost you 650 rupees. If you want drawing reading, quantity estimation, drawing and quantity estimation, site engineering, you can take it as a 60 days internship, where you will be getting 330 pre-recorded videos. It will cost you 999 rupees. Again, you get a course on professional site engineer, where you get site engineering, quantity estimation, drawing reading, then you get diploma in practical aspects, concrete technology, and basic project planning course. So that will cost you 1750. So you can download my Civil Brains app, or as I mentioned, you can get my courses from Udemy if you want to buy it from Udemy, right? So again, we'll move back to the video. So this is how your entire slab looks once everything is done, right? So you can see it here. Again, this is a small cantilever portion what they have. That means, see here, we have a beam here. So we have a beam here, I have a beam here, right? And in this much portion I don't have any beam, so it's a kind of a cantilever. So since this cantilever should not have a bit deflection, a more deflection and all, the structural engineer has given a kind of a concealed beam here. He has given more reinforcement in the form of a beam. So this all these things will be not mentioned in any of the code book. It's just a consulting practice what we adopt. So in order to reduce that deflection, in order to give this cantilever a bit more stiffness, what we are done is we are given additional reinforcement in the form of a concealed beam, and additionally you place a bar here. Okay, so this is the entire slab, everything is finished. And in the next lecture we'll try to see how the concreting is to be done, and also we'll try to see how the quantity estimation for this is worked out. Not for exactly this, but at least I'll give an idea how this will be prepared in the Excel sheet in the quantity estimation course of mine. And then we'll do the concreting of this, and we'll see how the slab will look once all the concreting is done. So I hope you have enjoyed the lecture up to here. Please do subscribe to the channel, and you can even download the Civil Brains app. You can buy the courses, which is at a very less price as of now. It may change, and many students of mine have also got a job also after finishing of the course. I don't guarantee any job, but my courses will help you to at least face the interview. That much amount of confidence you can get from my course, and that is how the course is made all about, right? So we'll see you back in the next lecture. Thank you.